As we've seen throughout this course, Angular modules are a key part of any Angular application. Welcome back to Angular 2 Getting Started from Pluralsight. My name is Deborah Kurata, and in this course module, we focus on Angular modules and how to use them to better organize our code. Ooh, it's so beautiful. No, it's not a Van Gogh, not even a Picasso. And yeah, it sort of looks like a metro map. This is a picture of what our application could look like if we leverage the power of Angular modules. Instead of one large app module like we have now, there are multiple modules, and each piece of our application has a logical place within one of those modules. This keeps each module smaller and more manageable. In this course module, we take another look at the definition and purpose of an Angular module. We then focus in on the Angular module metadata to better understand how to use it. We leverage that knowledge to create a feature module for our application, and take it one step further, defining a shared module to reduce duplication. Lastly, we re-examine our application's root Angular module. Let's get started. What is an Angular module? As we've seen earlier in this course, an Angular module is a class with an ng module decorator. Its purpose? To organize the pieces of our application, arrange them into cohesive blocks of functionality, and extend our application with capabilities from external libraries. Angular modules provide the environment for resolving the directives and pipes in our components templates. We'll talk more about this in a few moments. And modules are a great way to selectively aggregate classes from other modules and re-export them in a consolidated convenience module. Browser module, HTTP module, and router module are all examples of this. And we'll create our own convenience module when we build a shared module a little later. An Angular module can be loaded eagerly when the application starts, or it can be lazy loaded asynchronously by the router. Lazy loading is out of the scope of this course, but is discussed in detail in the Angular documentation. How does an Angular module organize our application? An Angular module declares each component, directive, and pipe that it manages. Every component, directive, and pipe we create belongs to an Angular module. An Angular module bootstraps our root application component, defining the component needed to display our first template. An Angular module can export components, directives, pipes, and even other Angular modules, making them available for other modules to import and use. An Angular module imports other Angular modules. This brings in the exported functionality from those imported modules. An Angular module can register service providers with the Angular injector, making the services available to any class in the application. We can think of an Angular module as a box. Inside that box, we declare each of our components. If those components need any functionality, that functionality also needs to be defined within this box. The app component sets up the routing for our main menu using RouterLink and includes the router outlet directive. So it needs the routing directives, router service, and routes, which are defined in router module. The product list component uses ng model, so it needs the forms module. The product list component also uses ng-for and ng-if, so it needs the browser module. The product list component uses the product filter pipe, so it needs that too. The product list component also uses the star rating components directive, so it needs that as well. And so on until the box contains everything that each of our components needs. Saying this another way, for each component that belongs to an Angular module, that Angular module provides the environment for template resolution. The module defines which set of components, directives, and pipes are available to the component's template. Each declared component's template is resolved using only the capabilities provided within that module. Let's look at our product list component as an example. The product list components template uses ng-model, so ng-model must be available within this module. We achieve that by importing the Angular Forms module. The product list components template also uses a directive we created, the star component, so the star component must be available within this module. Since the star component is one we created, we can either declare the star component within the module directly, or we can import another module that exports the star component. Importing an Angular module brings in the functionality exported by that module. And we'd need to do one or the other, never both. We didn't need to think about template resolution much in our sample application up until now, because all of the pieces of our application are in one Angular module. But we will need to keep this in mind as we split our application into multiple Angular modules. Let's take a quick look at our current app module. Here is the Angular module we defined throughout this course. It is the application's root Angular module, and by convention is called app module. The app module imports the system Angular modules we need, including the router module, which is where we configured our routes. It declares each component and pipe that we created in this course. It registers the service provider for our product detail guard, and it bootstraps the application with the root application component, app component. We have a lot of information in here, and we're mixing up basic application pieces, such as our welcome component, with pieces specific to our product feature. And look at all those import statements. Let's journey through the ng-module metadata to better understand how Angular modules work, so we can then refactor our app module into multiple modules for better code organization. As we have seen, every Angular application has at least one Angular module called the root application module or app module, and an Angular application has at least one component called the root application component or app component. The app module bootstraps the app component to provide the directive used in the index.html file. We covered the bootstrapping process in the Introduction to Components module earlier in this course. The bootstrap array of the ng-module decorator defines the component that is the starting point of the application. This is the component that is loaded when the application is launched. Here are some things to keep in mind when using the bootstrap array. Every application must bootstrap at least one component, the root application component. We do this by simply adding the root application component to the bootstrap array of the root application module. The bootstrap array should only be used in the root application module, app module. As we build other Angular modules, we won't use the bootstrap array. Every component, directive, and pipe we create is declared by an Angular module. We use the declarations array of the ng-module decorator to define the components, directives, and pipes that belong to this Angular module. Here are some things to keep in mind when using the declarations array. Every component, directive, and pipe we create has to belong to one and only one Angular module. In our sample application, all of our components are defined in one Angular module, app module. It would be better to divide the components into multiple modules, with basic application pieces in the app module and feature pieces in appropriate feature modules. We'll do that a little later in this course module. As we separate out our pieces, it is important to remember that each component, directive, and pipe belongs to one and only one Angular module. Only declare components, directives, and pipes. Don't add other classes, services, or modules to the declarations array. Never redeclare components, directives, or pipes that belong to another module. This is a corollary to truth number 1. If we redeclare, then the component, directive, or pipe no longer belongs to one and only one Angular module. For example, The star component directive belongs to Module B, so we should never redeclare star component in Module A. We should only declare components, directives, and pipes that belong to this module. All declared components, directives, and pipes are private by default. They are only accessible to other components, directives, and pipes declared in the same module. So if we declare the star component in Module B, by default that component is not available to components in other Angular modules. We share components, directives, and pipes by exporting them. We'll talk more about exporting in a few moments. The Angular module provides the template resolution environment for its components templates. When we include a component in the declarations array of an Angular module, the component belongs to that Angular module. That component's template directives and pipes are then resolved within that module. When we use a directive in a component's template, like the AI star directive shown here, Angular looks to the module for the definition of that directive. If the component defining that directive is not declared within the same Angular module or exported from an imported module, Angular won't find the directive and will generate an error. For this example, the star component must be declared in the same module as the product list component, so Angular can find the template for the AI star directive. Or the star component must be exported from an imported module, never both. The exports array of the ng module decorator allows us to share an Angular module's components, directives, and pipes with other modules. We can export any of this module's components, directives, and pipes so they can be pulled in when another module imports this module. We can also re-export system Angular modules, such as Forms module and HTTP module. We can re-export third-party modules such as Material Design. Material Design is a set of high-quality user interface components, including buttons and dialogues. And we can re-export our own modules. Here are some things to keep in mind when using the exports array. Export any component, directive, or pipe if another component needs it. A module can export any of its declared components, directives, or pipes. Re-export modules to re-export their components, directives, and pipes. This is useful when consolidating features from multiple modules to build a convenience or shared module. We can re-export something without importing it first. An Angular module only needs to import the components, directives, and pipes that are required by the components declared in the module. But the Angular module can still provide capabilities to other modules that import it by re-exporting. In this example, a shared module exports the Forms module, even though it did not import it. So any module that imports the shared module will have access to the ng model and other Forms directives. We'll see this in an upcoming demo. Never export a service. Services added to the provider's array of an Angular module are registered with the root application injector, making them available for injection into any class in the application. So there is no point in exporting them. They are already shared throughout the application. An Angular module can be extended by importing capabilities from other Angular modules. The imports array of the ng module decorator allows us to import supporting modules that export components, directives, or pipes. We then use those exported components, directives, and pipes within the templates of components that are declared in this module. Many Angular system libraries are Angular modules, such as the Forms module and HTTP module we've used in this course. We can import Angular modules to use their capabilities. Many third-party libraries are also Angular modules, such as Material Design. We can import third-party Angular modules to use their capabilities. We can import our own modules to extend our application with additional features or share capabilities across several modules. We'll see that in an upcoming demo. And we could separate out our route configurations into its own module or set of modules and import that. Here are some things to keep in mind when using the imports array. Importing a module makes available any exported components, directives, and pipes from that module. Recall that we are using ng-model in our product list component for two-way binding. The ng-model directive is exported in the forms module. By importing the forms module into our app module, we can use ng-model in any component declared in our app module. Only import what this module needs. Only import modules whose exported components, directives, or pipes are needed by this module's component templates. Don't import anything this module does not need. Importing a module does not provide access to its imported modules. Let's look at that with a picture. Here we have app module, which declares the product list component, and a shared module that declares and exports the star component. App module imports the shared module, so the shared module's exports are available to the app module's component templates. This means that the product list component can use the star component directive. If the shared module imports forms module, then the forms module's exports are available to the shared module, and the star component could use the ng-model directive. But the forms module exports are not available to the app module, so the product list component could not use the ng-model directive. I've heard this rule also stated another way. Imports are not inherited. Note, however, that if the shared module re-exported the forms module, then the forms module exports are available to the app module, and the product list component could use the ng-model directive. So when thinking about the relationship between modules, think of a module more as a box than as a tree structure. Angular modules can also register service providers for our application. We can register services we develop, such as the product service we created earlier in this course. The providers array of the ng-module decorator allows us to register service providers at the module level. This is similar to the providers array of the component decorator that allows us to register services at the component level. Recall that at this point, our sample application registers the product service provider at the component level and the product detail guard at the module level. Here are some things to keep in mind when using the ng-module providers array. Any service provider added to the providers array is registered at the root of the application, so the service is available to be injected into any class in the application. Say, for example, we have a feature module called Product Module. We add the product service to the providers array of this module. At first glance, we may think we have encapsulated the product service into the product module, but that is not the case. Any service provider added to the providers array is registered at the root of the application and is available to any class, even classes and other feature modules. So if we want to ensure a particular service is encapsulated and only accessible within a specific component or set of components, add the service provider to the providers array of an appropriate component instead of an Angular module. Note that this is not the case for lazy-loaded services. See the Angular documentation for more information on lazy loading. Don't add services to the providers array of a shared module. As discussed in the Services and Dependency Injection course module, there should only be one instance of a service that is an application-wide singleton, so a service should not be included in the providers array for any module that is meant to be shared. Instead, consider building a core module for services and importing it once in the app module. This will help ensure that the services are only registered one time. We could even add code to the code module's constructor to ensure that it is never imported a second time. See the Angular documentation for details. Routing guards must be added to the providers array of an Angular module. We discussed this in an earlier course module when adding guards to routes. The guard service provider must be defined at the module level so that the router can use these services during the navigation process. Now that we've covered the basics of the ng module decorator, let's refactor our application into multiple Angular modules. So far in this course, we created the root application module, app module. It declares all of our components and our pipe. It imports the system Angular modules that our components need. It also registers the routing guard that we built. But this is getting a little unwieldy. We have no separation of responsibilities. Here we are mixing our basic application features, such as the welcome component, with our product features, such as the product components, with our shared features, such as the star component. As we add more feature sets to this application, such as customer management, invoicing, and so on, this is only going to get harder to manage. So let's reorganize and refactor to break this into multiple Angular modules. The first thing we want to do is extract some of these pieces into feature sets. We can then create a feature module for each feature set. Using feature modules helps us partition our application into logical groupings with separate concerns. Our first step is to define a new feature module. Creating a feature module involves defining a new module file, product module in this example, and reorganizing the pieces of the application so that all of the associated feature pieces and everything they need are here in this module. In the declarations array of the feature module, we add the appropriate components that provide the features for the application. In this example, we add the product list component and product detail component. Then, as we did with the box example at the beginning of this course module, we start to look at what each component needs. In this example, the product list component uses the product filter pipe, so we need that. And both the product list and product detail components use the star component, so we'll need that here as well. But that's not enough. The product list component uses ng model and ng4, and both components use ngIf and routing. How do we get that? We import these needed capabilities from other Angular modules. Our product components use routing, so we import the system router module. The product list component uses ng model, so we import the system forms module. And we need ng4 and ngIf. So do we pull in the system browser module? Nope. The browser module should only be imported into the root application module, app module. Instead, we import the system common module. The common module exposes the ng4 and ngIf directives. Not surprisingly, the browser module itself actually imports and exports the common module, which is why we have access to ng4 and ngIf when we import browser module in our app module. Lastly, we add any related services we want to declare at the module level, which make the services available to be injected into any class in the application. In this example, we add the product service and the product detail guard, which must be at the module level. So even though these module level services are available application-wide, we include them in the product module and not the app module to keep the code better organized and easier to find. Our feature module is looking pretty good here, but how do we use it? Now that we've removed these features from the root application module, how will the application find all of these features? What's that? Imports array, did you say? That's correct. We need to import the product module into the app module. That extends the app module with the product module features. Want to try this out? We are back in the sample application. Let's begin by adding a new file for the product module. We'll add it to the products folder and name it product.module.ts. We start with the class. We add the ng module decorator and the required import statement. We add the declarations array, and in that array, we add the product list component, product detail component, and product filter pipe. We also need the star component. All those red squigglies? Yeah, we need some import statements. Now we can remove these from the app module. Next, we define the imports array. We'll add the Forms module, Common module, and Router module, and their associated import statement. Now we can remove the Forms module from the app module and its associated import statement. When we added the Router module to the imports array in the app module, we called forRoute to pass in the configured routes for our route component. Now that we are adding the Router module to the imports array of a feature module, we don't call forRoute. Rather, we call forChild, and there we pass in the routes related to products. Let's cut the product routes from the app module and paste them here in our product module. And we need to import the product detail guard. Recall that the Router module registers the router service provider, declares the router directives, and exposes our configured routes. But as we've discussed previously, we never want to register a service more than once. So when we use forRoute to pass in our configured routes, the Router module knows to register the router service provider. When we use forChild, as we did here, the Router module knows not to re-register the router service. Note that we could also consider moving the routes into their own modules. We'll look at that a little later. Lastly, we add the providers array. We add the product service and product detail guard to that array and insert their appropriate import statements. Now we can remove the product detail guard and its import statement from app module. Let's remove some of our remaining import statements and the product service from the app components providers array. Moving the product service to the product module is optional. We could leave it in the app components providers array. Now, do you think our application will run? Our welcome page comes up, but clicking on the product list option does not display the product list page. Any idea what could be wrong? We now have this product module, but our application, which is bootstrapped with the app module, doesn't know anything about this new module. We have to import this module in our app module. So here we add the import statement and add the product module to the imports array. Now we should be good to go. And our application works as expected. So we now have our first working feature module. But let's think about this for a moment. As we build our application, we'll build more features. Each logical set of features will have their own feature module, and each feature module will most likely need the common module for common directives such as ngFor and ngIf, the Forms module for ngModel and two-way binding, and we may have other features that want to reuse our star component. Do we really want to repeat all of this in each feature module? There has to be a better way. Yep, we can define a shared module. The purpose of a shared module is to organize a set of commonly used pieces into one module and export those pieces so they are available to any module that imports the shared module. This allows us to selectively aggregate our reusable components and any external modules and re-export them in a consolidated convenience module. Creating a shared module involves defining a new module file, shared module in this example, and reorganizing the pieces of the application so that the shared pieces are here in this module. First, we add the components, directives, and pipes that we want to share throughout our application to the declarations array. In this example, we only want to add the star component. Then we add to the imports array anything that this shared component needs. In this example, we import the common module because our star component may need it. We don't import Forms module because we don't need it here. If our star component did use two-way binding, or we added another component here that did, we'd need to import Forms module as well. We then need to export everything that we want to share. The exports array defines what this Angular module shares with any module that imports it. We export the star component. That way, it is available to the components in any module that imports the shared module. We re-export the Common module and Forms module, so their directives and other features are available to any module that imports the shared module. And notice here that we can export something without importing it first. To use the shared module, we import it into every feature module that needs the shared capabilities, such as our product module. Let's give this a try. We want to build a new shared module. We'll add it to the shared folder that was provided with the starter files. We'll begin by adding a new file and name it shared.module.ts. We'll start with the class and add the ng module decorator. And we of course need to import that decorator. Next, we define the declarations array and add the appropriate components to that array. In our example, we'll add the star component, and we'll need its associated import statement. Next, we define the imports array and add the common module and its associated import statement. Lastly, we define what we actually want to share. In the exports array, we add common module, forms module, and star component. And we need one more import statement. Now we want to use this shared module in our product module. What do we need to do? We start by adding the shared module to the imports array of the product module. And we need its import statement. We can now delete forms module, common module, and the star component and their associated import statements here, since these pieces are now coming from the imported shared module. Are we good to go? Yep, our application comes up as it did before. Looking back at our code, notice now that our feature module, product module, only contains product pieces and the shared module. And the shared module is clean, only including the pieces we want to share. We can reuse the shared module in any future feature modules as we add functionality to our application. We now know that every application has a root application module that is by convention called app module. The main purpose of the app module is to orchestrate the application as a whole. And now that we've removed the feature and shared pieces from this module, its purpose is easier to see. Let's take another look. We've reduced the code in app module such that it now fits on one page. The app module normally imports browser module. This is the module that every browser application must import. Browser module registers critical application service providers. It also imports and exports common module, which declares and exports directives such as ngIf and ngFor. These directives are then available to any of the app module's component templates. We also import HTTP module to register the Angular HTTP client service provider. We import router module and call for route, passing in the configured routes for the root of the application. Here we configure our default route and any wildcard routes. Then we import each feature module. In this example, we have only one feature module, product module. The declarations array identifies the list of components that belong to this module. In this example, the root component, app component, and the application's welcome component are declared here. The bootstrap array identifies the root component, app component, as the bootstrap component. When Angular launches the application, it loads this component and displays its template inside the PM app directive in the index.html file. We could take the refactoring a step further and separate the routing into its own module. We could create one Angular module for our root application routes and another Angular module for our product feature routes. Let's go back to the slides and see what that code would look like. If we wanted to refactor our root application routes into their own module, this is what it might look like. We export a class, add the ng module decorator, and import what we need. We add the router module to the imports array, passing in our root application routes, including our default route and our wildcard route. Notice that we call for root here to ensure that we register the routing service provider. And we export router module so we can use it from any module that imports this module. We import the app routing module in the app module here. We can do the same to refactor our product feature routes into their own module. The key difference here is when we import router module and any feature module, we pass the configured routes to the forChild method instead of the forRoot method. This ensures that we don't register the routing service provider a second time. And we import this product routing module into the product module as shown here. Now let's finish up this course module with some checklists and a summary. Your application architecture depends on many factors, including the size and scope of the application you are working on, your team's size and experience, and your project's goals. But here are some suggestions based on what we covered in this course module. Every application must always have a root application module, by convention called app module. This is normally the module that bootstraps the root application component, app component. For smaller applications, this could be the only Angular module for the application, as was the case with our sample application prior to this course module. As the application gets more features, consider defining a separate Angular module for each feature set. For example, a product module, a customer module, and an invoice module. This keeps the code organized, separates the concerns, and prevents the app module from getting excessively large and unwieldy. As you add feature modules, you may find components, pipes, and directives that you want to share across feature modules. Define one or more shared modules for these shared pieces. Shared modules primarily use the exports and declarations arrays, with most of the declared pieces exported as well. If you have a set of services that you want to ensure are loaded when the application is loaded, consider defining a core module for those services. Be sure that the core module is imported only once in the root application module. Since a core module is for services, they primarily have providers, none of which are exported. We did not create a core module for our sample application since our service needs are limited, but you may find them useful for your applications. And as we discussed in the last clip, we can also refactor our routes into their own routing modules. When creating an Angular module, we build a class and decorate it with the ng module decorator. The ng module metadata includes the bootstrap array for defining the list of startup components. In many cases, there is only one, the root component of the application. The declarations array declares which components, directives, and pipes belong to this module. The exports array identifies the list of components, directives, and pipes that an importing module can use. The imports array lists supporting modules. These modules provide components, directives, and pipes needed by the components in this module. The providers array lists the service providers. Angular registers each provider with Angular's root application injector, so these services are available to be injected into any class in the application. This course module was all about Angular modules. We took a second look at the definition and purpose of an Angular module. We then focused in on the Angular module metadata and covered the truths to keep in mind when using that metadata. We leveraged that knowledge to create a feature module for our application, and took it one step further, defining a shared module to reduce duplication in our application. Lastly, we re-examined our application root Angular module and saw how it orchestrates the application as a whole. If you are building a small application, such as the sample application we've created in this course, you may only need the one root application module, as shown here. But as your application grows, you'll want to refactor into feature modules and shared modules, like this. Here we organized our application into multiple modules. We have our feature module, product module, that encapsulates all of the product features. There will be more feature modules as our application grows. We have our shared module that shares commonly used components, directives, and pipes with any module that imports it. Currently, we import it into the product module. As we build more feature modules, we'll import it into them as well. And we have our app module that orchestrates the application. Each feature module is added to the app module's imports array to extend the application with those features. Whew, it's been quite a journey. Now let's circle back to the beginning. When we set up Angular in the First Things First module, we skipped over the explanation of the setup files. Next up, let's revisit the Angular setup process and look at these boilerplate files, what they are, how to use them, and when you'll want to change them.